So far in trigonometry, all we've been dealing with was right angle triangles. So now we're moving on to when they're not right angle triangles. So just to kind of quickly recap, like when they are right angle triangles, you're thinking of two things. You're thinking of your Pythagoras rule, and then you're thinking of your trigonometric ratios, and this is when you're solving for unknown. Okay, but when they're not right angle triangles, there's going to be two different things that you're thinking of, and that's going to be either the sine rule, which we're going to cover now, or it's the cosine rule. So I think trigonometry, if you break it up as simply as that, you'll find it an awful lot easier. So it's either the triangle that they give you on the day is either right angled or it's not right angled. If it's not right angled, sine rule is one of our options. Okay, so as you can see from the pictures I put up here, the 4 triangles I have up on this page, none of them are right angle triangles, so I'm either going to use sine rule or cosine rule to solve them. A few things you need to recap on. So like everyone, you all need to know that the 3 angles inside a triangle add up to 180 degrees. You also need to know about, hang on, I just grabbed my pen. You also need to know that, like, say if I just grab this angle here, B, so angle B is always opposite side B. Angle A is always opposite side A. And angle C is always opposite side C. And as you can see from the diagrams, and this is always through trigonometry now, the side will always be a small lock, so small letter, and the angle will always be a capital letter. So it's like small b, large B, if that makes sense. So if we look at our formula, so this is our formula that's given in our log tables for the sine rule. So A over sine A is equal to B over sine B is equal to C over sine C. Okay, so like I've just told you now, so that means side, because that's a small letter, over the sine of the angle opposite is equal to the side of its angle opposite is equal to the side over the angle opposite. A lot of the time, we'll only be working with 2, so you don't, like, when you are solving for sine rule, you'll only actually have 2 things equals, say if we pick B over sine B. You never will do out the 3 of them. There'll be no need. But what you should be recognising straight off from this is what I've actually ended up with is a fraction equals a fraction. And alarm bells should be going off in your head, because you know if we have a fraction equals a fraction, we can actually cross multiply. And this will help us for our solving part. So when do we use, so that's just kind of a small introduction. When do we use the sine rule? So there's 2 different reasons why we use the sine rule. So of course, without stating it here, it obviously can't be a right angle triangle. But then the other time is, so if we look at this triangle just here, if we're given 2 angles and we're given one side, but they want us to find the other side. Ultimately, like, you know straight away that they've given us 2 angles, so they give us 95 and 32. You actually know that third angle, because you can just add 180, or add the 2 of them together and subtract from 180, you have your third angle, so you have 3 angles one side. Another time you use it if you're given 2 lengths but only 1 angle and you're asked to find another angle. So always remember as well, it's an important note to remember, if you're finding an angle, don't forget about the inverse. So if you want to find sine A equals whatever, if you want to find the angle, remember your sine becomes your inverse. So just don't forget that either. So we'll do an example here now just to help you with sine rule. Okay, so we're going to use the example that we just talked about above. So the first thing that you have to do, if they don't give you a diagram, make sure you draw a diagram really clearly. Input your angles and your sides and highlight what you're looking for. So in the diagram here, we're obviously looking for side P because that's the unknown. And the first thing I would do though is like join them. So I know this angle 32 degrees is actually belonging to side P, and I know that the side or angle 95 degrees is actually with 21, because they're opposite each other. So I'm going to have my formula, so I'll go to my log tables, and I know it tells me that the side of A, so A over sine of A, is equal to B over sine of B. I only have to use 2 because I'm only working with 2 sides and 2 angles. So I'll sub in what I know on my sides, and just as you know, it will always be sine on the bottom. It will never be cosine, and never be tan, because this is the sine rule. And always ensure you put in the sine. You don't just write 21 over 95. It has to be 21 over sine 95, and so on. And so we'll fill in. So I go with this side first. So my side is P, and my opposite angle to that is 32. So I put over sine 32 is equal to, so my other side is 21, and my side opposite, or angle that works with that, is 95. So as you can see, I have one unknown, and that's the ideal, like, because you want to solve for your one unknown. My unknown is P. As I said earlier above, you have a fraction equals a fraction, and you should know this from algebra. I can then cross multiply. So the two things on the bottom are divisors, so if they cross equals, they actually become multiplication. So I'm going to bring my sine 95 up and multiply it by my P, so that'll just give me P sine 95 equals, then my sine 32, I'm going to bring that up, so it becomes a multiplier, so it's going to multiply by 21, so I have 21 sine 32. At this stage, you can do out your numbers, like you could put sine 95 into your calculator, and that would give you 0.9962. So you'd have P bracket 0.9962 equals 21 sine 32. So it should be 11.1283. I'd always keep it to 4 decimal places until the very end, and then solve for P. But it's just as easy, like, you know that the P and the sine, you know that P and sine 95 are actually multiplying. So if I want to find P, which I do, I just get P on its own. So the sine 95, which is multiplying, goes across and becomes a divisor. So P is equal to, so put this into your calculator, so 21 sine 32, close your bracket, over sine 95, close your bracket, equals 11.17, and say this head to the nearest whole number, so we know our side P is equal to 11. Draw it in on your diagram then once you've found it, because sometimes there'll be another diagram here or triangle there that you might have to find something else within it. So it's a good idea to always draw it on your diagram, because it can continue. Okay, so if we have two sides and one angle, so as we did before, just match them up. So this one belongs here and here. So we'd write in our formula, so we have A sine A is equal to side B over sine of angle B. So I'm going to have my side, I'm going to go 3.6, and I know my angle opposite to that is sine of B. Now really they should have called that a capital. And then my other side is 5.1 over my sine of 100. And don't get thrown off because these are called A in our log tables and B in our log tables. Just like think of them as side and the angle opposite, side and the angle opposite. Don't worry that they're called A, B, because like that B could throw you off here when it actually really shouldn't. It's just side over. Right, I've only like 50 seconds left before this video cuts out, so I'm going to do this really quite quickly. So you're going to have your 3.6 sine of 100 is equal to 5.1 sine of B. Okay, we're trying to find B, and we know that 5.1 and sine B are multiplying, so sine B, put in our 5.1, is equal to 3.6 sine 100. We want to find sine B, so we get 3.6 of sine 100, and we divide it by, what's that number there? I have 5.1. I want to find B, so I have to get the inverse sine of this, 3.6. This is going to run out, but you should be able to